All right, guys, in this video, we're going to talk about how to model with exponential functions. So those are like those word problems that we started doing last class. Okay, so each time we're looking at a word problem that has to deal with exponential growth or decay, we have what we call a growth factor or a decay factor. And you might recognize this from Algebra 1 again. So growth factor, remember that's the stuff that I was talking about. If I start with the original amount, that's 100% of the original amounts. So if I'm starting with 100% and I want to add an additional percent to that, so I don't know how much percent, however much I'm adding, that's going to be over 100%. Okay, so 100 and something percent. All right, but as a percent, we don't ever put that percent in our equation. We want to put that in as a decimal. So remember that whenever we have something like 103%, I want to move that decimal point 2 times. So that's going to become 1.03. So basically, your growth factor is going to be 1 plus whatever your percent growth is as a decimal. Okay, so this is going to be a decimal. And that growth factor is what your B value is. So the growth factor and decay factor, that's your B. That goes in the parentheses, that's going to get raised to the X factor. Okay, that's your growth factor. Decay factor is the same thing, except instead of adding on to 100%, we always start with that original amount, 100%. We're subtracting a percentage from that. So that's going to be something that's lower than 100%. So it might be like 80% or 73%. So if I had something like 73%, again, I'm not going to use 73% in my equation. I'm going to move that decimal point 2 places to the left. So 0.73 is what I would use as my B. Okay, so your decay factor is going to be 1 minus whatever this is as a decimal. So let me show you how that works, just so you can make sense of all of that. So in the last 12 years, an initial population of 38 buffalo, that's our original amount. Remember, that's our A value. In a state park, it grew by 7% each year. Okay, so we're going to write an exponential growth model giving the number of N buffalo after T years. So remember, this is just instead of Y and X, we're using N and T. So don't let that throw you off. So and then after we do that, then they want us to figure out about how many buffalo were in the park after 7 years. So there's 2 parts to this problem. So first we're going to write, we said our A is 38. That's our starting amount. Our B is going to be 100% plus the 7%, right? So that's 107%, but I don't want to put 107 as my B. I want to move that decimal point twice. So I'm going to put B is 1.07. So my equation is going to be, if we were doing Y and X, it would look like this. Y equals 38 parentheses 1.07 raised to the X power. The only thing I'm going to change is instead of Y, I'm using the variable N for number of buffalo. And instead of X, I'm using T for the number of years. T is always for time, and that's the number of years. So that's our first answer, okay? That's our exponential growth model. It's just the formula that we're using. So for the second part of our problem, it says how many buffalo were in the park. So we're trying to find N, and we're plugging in 7 for T. So you're going to get your calculator out and plug that in. So when you do that, you get about 61.02. So if we had to say how many buffalo there were, we would say 61 buffalo. Because 61.02 doesn't really make sense for buffalo. Okay, So let's talk about compound interest. This is very important. Exponential growth and decay is so important in the financial world. So compound interest, we have a few variables going on here. We have a principal, initial principal, remember that just means your starting amount. Okay, and we're depositing that into an account, and it pays an annual interest rate. So your R is always going to be a percent as a decimal, and that's what it says there. It's compounded n times. So how many times do they calculate the interest per year? Is it twice a year? Is it every month? So would that make that 12 times a year? So that's the n. And then the amount A is the amount in the account after t years. So t, like I said, is always time in years. So what does that formula look like? So the amount in our account is P parentheses 1 plus R over N to the NT power. So let's look at an example. So we're going to deposit $2,900. That's how much you're starting with. That's my P. So I'm going to write this. P is equal to $2,900. And our account pays 3.5% annual interest. So my R is going to be, remember, we're moving this 2 times. So be careful here. This is going to be 0.035. They want us to find the balance after 1 year. So 1 year, that means T is equal to 1. And it says it's compounded monthly. So the only thing you might have trouble with is the compounding, because it won't look like a number, it'll be a word. So monthly means 12 times a year. And then they want us to do it again and do it annually. So for monthly, our N is going to equal 12. For annually, that means once a year. So our N is going to equal 1. Okay? So if I plug all of this into my formula, I'm going to get 2,900 times 1 plus 0.035 over, I'm doing the monthly one first, 12 to the 12 times 1 power. So I'm going to type all of that in to my calculator, just like I see it, and I want you to do the same, and then we'll compare answers. So when I did that, I got 3,003.14, and I'm rounding to the nearest cent, so I got to put 2 numbers after the decimal place. Okay, so that's how much will be in my account if I let that 2,900 sit in that account for a year, and my interest is compounded monthly. So now, how would this change if it's annually? The only thing that changes is the N. So instead of doing 12 for my N, I'm doing 1. So again, I'm going to type all that in, or you can copy and paste on your calculator if it does that for you. And now I got 3,001.50. So a little bit less than when it's compounded monthly. So obviously the more times it's compounded, the more money you make. Okay, so let's look at this second example. We paid $5,000 into account that pays 3.72 annual interest rate. So again, our P is 5,000. The R is, we're moving that decimal twice, so 0.0372. We want the balance after 3 years, so that means T is 3, and it is compounded quarterly. So the word quarterly means 4 times a year. So N is equal to 4. So you just plug all of those numbers into the correct spot. So I got 5,587.45. So we've made $587.45 in those 3 years, just for leaving our money in that account. Okay, so that's the idea behind compound interest. So I want to talk about next is the natural base E. E is equal to approximately 2.71828, and it keeps going. E is a number, is irrational, like the number pi. Okay, so I need you to understand that E will go on forever and we can't ever be exact with that. So the reason I want you to know about that is because we use E when we do compound continuously. So continuously, we have no way to tell how many times a year that is. It's like infinity times every year. So we can't plug in infinity for n, so instead we are using this E formula. I always think it looks like the word PERT. A equals PERT. So if that helps you remember that formula, then use that. But again, P is your principal. That's your starting amount. And then E is a number. So you're not going to be plugging anything in for E. R is your percent, written as a decimal. And then T is the number of years. Okay? So let's do an example. So we deposit $3,500 in an account that pays 4% annual interest that's compounded continuously. All right, so this is our P. Our interest rate is, remember, move this decimal point, 0.04. And compounded continuously, that means I'm going to use PERT. So I don't have an N this time. I'm just going to use a PERT. All right, and then T is equal to 1. So I'm going to plug that in. A equals 3,500 times E to the RT power. So your E button on your calculator, well, it might be in different places, but you want to look for either E or sometimes it has LN on it, and sometimes you have to do the second button. So whatever you need to do on your calculator to get the E button to come up, but there should be a specific button for the number E. So when I typed mine in, I got 3,642.84. Okay, let's do one more and then we'll be done with compound examples. All right, so our P, our deposit is 4,800. Our rate is 0.065. We are compounding continuously, so that means we're using this formula. And then our T is 3. So we got 48 times E to the 0.065 times 3 power. So let's see what we get. I'm going to type that in. Hopefully you found your E button. If you did not, you need to ask me about that when you get into class. So that gives us 5,833.49.